Well, hello, pre-calculus class. Today we're going to be learning chapter 9.4, variability theorems. The first theorem we're going to learn is called Chebychev's theorem. And so if you look there on page 462, example number 1, Chebychev's theorem says, it tells us what portion or percent of the data lies within a certain standard deviation of the mean. This is the theorem, 1 minus 1 over k squared, where k is the number of standard deviations from the mean. So remember, when you go out of standard deviation, you're going out of standard deviation on both sides of the mean, not just on one side. We're not just going up, we're going down also. So we have to remember to keep that in mind as we do our work. So come with me, we're going to go look at a little land and farm tradition of looking at our pond, and we're going to go see our fruit trees. Come for a little tour. All right, here we have our lazy river, which is right here at the NID canal. And what we're going to do is look down here. We have this wonderful, beautiful water. It feeds my pond. And when during summertime, it's just nice to sit by this little creek. Come on down here. This is my pond, but there's no water in it because we don't get the water until April 15th. And this is my son. He's spraying weeds in the pond. He's really happy about being on my video. And so actually, let me show you a little bit over here. I've got the sun look like this. So example number 1 says, what portion of the data must, this is a must always lie within 3 standard deviations of the mean. This is dealing with Chebychev's theorem. So what we do is we plug in number 3, because I want to know 3 standard deviations out. Remember, standard deviation is just the average distance away from the average, right? So how many, if I do that 3 times, then what would be the answer? Well, plug a 3 in there. 1 over 9, right, would be 1/9. 1 take away 1/9 is 8/9. That means that 8/9 of the data would be within 3 standard deviations, right? So if you look at it, this is a great graph here for you. It says 8/9 of the data must lie between the 3 standard deviations of the mean. If this is the mean, we got 1 standard deviation, 2 standard deviations, 3 standard deviations. Then if this is all the data, 8/9 of the data will be within the 3 standard deviations of the mean. Come with me. Let's keep on taking a tour of the land and farm. We're now going to enter my wonderful fruit tree realm where I can sing to my trees. They like it when I sing to them. They grow more better that way. Hold on. This here is a persimmon tree, and it's a beautiful tree. It just started sprouting, and we'll get some persimmons this summer. Let's keep on going here with example number 2. Maybe we can move it better. Is the sun okay over here? I'll stand. I'll show you my this over here. This is pomegranates. Let me show you pomegranates first. This is my beautiful pomegranate bush/tree, and I will be happy to do example number 2 right in front of it. So example number 2 says, page 462 in your book, check to see if Chebychev's theorem works for k equals 3 given this data. Right? Remember that it was only supposed to have, we had to have 8/9 of the data within 3 standard deviations. So let's see if it works. So if we say that our mean, or our x bar, is 9, right? If I add those up and find the average, I'm going to find out it's 9. I'm going to find out that my standard deviation is 2.59. So remember, I'm going to go out 2.59 this way and 2.59 that way. That would be 1 standard deviation. If I do 2.59 again on either side, that's another standard deviation. I got to go out 3 standard deviations. If I do that, that's 9. This is not 9 over x. This is 9. That's my x bar. X bar is 9, my average. My mean is 9. If I go out a standard deviation, I add 2.59 up that way, and I subtract 2.59 the other direction. That's 1 standard deviation, 2 standard deviations, and 3 standard deviations. So over here, I'm adding, this is 9, plus 3 standard deviations. I don't know if you can see that. So 9 plus 3 times standard deviation. Over here, this is 9 minus 3 times standard deviation, if you multiply that. So 9 take away 3 times the 2.59, and 9 plus the 3 times 2.59. When you do that, that tells you 1.23 to 16.77. That is 3 standard deviations. My data should be between 1.23 and 16.77. I should have 8/9 of my data in there. Well, do I? So 8/9 of the data should be between 1.23 and 16.77. Well, if you look at my data and you look at it, the only number is just the number 1 that is outside of this range. All my data is between 1.23 and 16.77, except for the very first term, right? So it's true. Only one of the values of the data is outside of that, right? And I was allowed to have 1/9 of the data out of that. If there's 18 different terms, 1/9 of the data would be 2 terms are allowed to be outside of it, and I only had one, so it fits in it. Everything's all good. We should go see my sheep, but first I have to run. A minor, A minor. All right, let's go check out my sheep. Okay, so here's my wonderful sheep. Some of them are a little bit skittish, but we gotta find Spot, because Spot's the nice one. And she'll cuddle. We're gonna have to cut that out. There's Spot. Yeah. This is my wonderful little sheep, Spot. She's named Spot because she's got a big old spot right there. And I think she's pregnant. Okay, we're gonna keep on going here. So the empirical rule goes right alongside Chebychev's theorem, which talks about how much data percentage-wise should be in the 1 standard deviation, up and down, both sides, 68%. 2 standard deviations is 95%, and 3 standard deviations is 99.7% of the data. No matter what data you're getting, this should hold. Okay, so if we go over here, I gotta show you my llama. Come over here and let me show you my llama. She's really skittish, so she'll probably not want to get anywhere close to me. Hello, llama. Her name's Tina, like in Napoleon Dynamite. Oh yeah, she's running away. So we'll just continue on here. So in example 3, our last example today, page 463, we're going to say, show that the empirical rule applies to this data set, so that bell curve, right? So if we have our data here, and I list them out in order, I say, how many 3s did we have? Well, there it is right there. We had 1 3, so I said I have 1 3. How many 4s did we have? Look for the 4s. Right, I have 1 single 4, right over there. And over here we have like 8 5s.
5 8.
5 8s, do over. 5 of these 8. So if I went over 1, 2, 3, 4, 5 8s, right? So if you look at all this and you were to graph them onto this bar graph, it would look kind of like this bell curve here, okay? And if you look at the standard deviations of it, if I took my mean, if I found the mean of this and I went right down the middle, found the mean, the average, my x bar, and I said I want to go from a range of my mean minus my standard deviation to the mean plus the standard deviation. That's that one section in our, that'd be the first standard deviation right here, right there. If I want to say how much is in that, right? Then when I do that, that's going to say it's going to go from a low of 5.6 to a high of 9.6. Well, how much data does that get? Well, it gets 14 of our 20 numbers. If we have 20 numbers up here, it's going to get 14 of those, which is 70% of the numbers. Now, remember, I had to get at least 68%, and it fits. I got 70%. It's even better, 2 percentage points more than I needed. If I do that with 2 standard deviations, my x bar, my average, take away 2 standard deviations and plus 2 standard deviations, 2 of them out that way, then that's going to have 19 out of my 20 numbers, which is 95%. That's perfect. And then my 3 standard deviations here goes to a 20 out of 20. I get all my numbers. I needed 99.7%. I even better. I got 100% of my numbers in there. So yes, it works. So Chebychev's theorem and the empirical rule work. This is fantastic. Landon out.